All right, welcome back to another network automation video. Last video, we ran into a snag. I couldn't figure out what was going on, but it wouldn't let me log in. The message was, this protocol error we were getting, and then we figured out how to get a different error, socket error. I don't know if that means progress or the opposite of progress, but in between videos, I tried to look into it some more. I found out that so one of the things I did is I just moved ahead in the book and saw if this affected everything I did on Aristas or just using that one library. It did affect all the other libraries, but the next thing in the book was for Python 3. So since that one was for Python 2 anyway, it's not a big deal. Hopefully I won't be using any Python 2 or won't have to use that to accomplish the goals I would need to be using something like this for. I did notice on the Arista, if you do a show run, my management API commands was missing some configuration that I thought would be important to have on there. It looks like it's not on there still, but if you look at, and I don't know what is up with Aristas where sometimes you just straight up can't. Oh, okay, there we go. So you can see I've got an option for protocol, and then on top of that, HTTPS. So it looks like it's just for options, but you can see I do have this CR here. So I was wondering maybe I don't have the right, without that enabled, without that enabled, I was wondering maybe that was the issue. So I tried changing that. I removed all the things I tried to do with SSL. Unfortunately, it didn't lead to the Python 2 example working, but it did lead to the Python 3 example now working. So where I left off in between videos, I had just done this example here where I do a pprint on that. So I'll just do that example again just so that it's on video. So I got to go to Python and it'll open Python 3, import Py eAPI. So this is just like PyEZ for Juniper Gear, but Arista has their own version of that library. And then one kind of really nice thing that Arista has is a configuration file that you can set up. So you don't gotta put all your username and password information actually in the terminal as you type it up. You just have this special function, pyapi.connect to, and we'll take a look at the help on that. Yep, and it creates a node instance based on an entry from the config. So it will hopefully call out the file it's reading from. I guess I don't see where, I don't see it mentioning anything about it, but let's read some more. This function will retrieve the settings for the specified connection from the config and return a node instance. The configuration must be loaded prior to calling this function. So I did that. I created the configuration file. So let's continue on. So let's take a look at, before we continue on, the help, or let's take a look at the type of this Arista1 variable that we defined. So yep, it's going to be a class, so client node. Let's take a look at some help information for it. So we can do all sorts of things. We can send config. So we can do enable authentication, all sorts of things we can do. let's do the enable. So let's get help on that. Arista1.enable. Yep, so sends the array of commands to the node in enable mode. This method will send the commands to the node and evaluate the results. If a command fails due to an encoding error, then the command set will be reissued individual with text encoding. So really great library, a lot of really good text. As I mentioned before, all of that text that we're reading in the help, the programmer put it in there to let us a hand. So the better the programmer does at that, the easier it is to use the module. So if we're writing our own modules, which we're gonna probably be doing, having that help available is going to be essential. And it's not just essential for the people using it, it's essential for yourself as well, the person who wrote it. Oh, so we got to import preprint. So there we go. We get the commands show hostname, coding JSON, and the result hostname is localhost. And the FQDN is also localhost. All right, perfect. The configuration field can be either a single command or a list of commands using the config method. So let's try that. Arista1.config hostname Arista1-new. Oh, and it's got to be Arista, not Arist. There we go. So we got back the output they were looking for. So now let's do that show host name again, and we'll see that it has been changed. Perfect. We changed it to a wrist. I don't know why I can't type that A. Maybe it's just my pinky's not strong enough or something like that, but it's something I gotta be careful about when I'm working on these. Make sure I type Arista, not a wrist. But let's set up a description on an interface. Arista. So I'm not sure we have Ethernet 1-3, so I'm just going to put it on Ethernet 3. Oops. Oh, there we go. Perfect. So now we get two of these things back because we sent two different things. So note that command abbreviations, show run versus show running config, and some extensions will not work. Okay, well, that's too bad, but it's not a big deal to use the full command. And then you can get more information about what's happening if you just have, S space R, what are you really, and somebody comes back and reads your code, you're violating those principles of readability and reusability of your code. Okay. So that might be even a feature, not a bug. All right. Oops, and we didn't get to the, so yeah, oh yeah, this is what they're trying to show us, is that we use show run instead of show running config. And it failed because, right here, incomplete token, right here. Incomplete token for run, and it says run. It's run, it's not running config, that's a complete token. So it's not gonna work unless we use the complete token. So let's do that now. Oh, same thing again. We got an incomplete token. interface. I think the full thing is interfaces. So, but one thing you can always do, because it's going to be returned to you in a JSON payload, however, you can always catch the results and get the desired value. So results equals Arista 1.enable show running config. Perfect. So let's see what we get back. We get back a list. So let's see how many elements are in this list. Oops. Lists definitely do have, oh, it's a class, it's not an element, sorry. So let's get some help on that. Oh, no, it is a list. Why is it saying lists don't have, oh, I did length list, I didn't do length result. There we go. So it's just sub length 1. Really nice and easy. So let's do pprint result 0. It's the only one in there. And then we're going to get results, CMDS, internet, and we're using Ethernet 3. All right, so this should be good. We're also going to need, oh, that's the return output. Oops. So there's a key error here. So interface Ethernet 3. So let's take this as a good learning opportunity to learn about other kinds of Python data types. This is going to be a dictionary data type. So we've got different things we can do to different kinds of Python objects depending on their type. This is a dictionary type, so we can do all sorts of these things. So we can even just take a look at what kind of keys we have available, which is going to be, of course, very useful to us because we tried to use one that we don't have. Okay, so we've got these keys: command, result, and encoding. Let's take a look at the value of the command key, or, sorry, the result key. So we've got a whole bunch of stuff. It looks like it's another dictionary, so we'll do a type on that. Yep, so it's another dictionary, so it's going to have the ability to show us the keys. So we got more options under here. We've got header, comments, and commands. Let's go with commands. And let's see what type this is. So it's another dictionary, so we're going to have that keys method that we can use on it. And oh, we've got all kinds of keys here. So do we have, oh, we do have internet. Oh, okay, so here's the problem. We were using a space, Ethernet space 3, but there's no space in the actual key. So of course the key with a space does not exist. The only key that exists doesn't have a space between Ethernet and the number 3. All right, but now we're getting our description back. Description, my link, perfect. Everything is matching the example. So let's continue on. So far we have been doing what we have been doing with eAPI for show and configuration commands. eAPI offers various APIs to make life easier. In the following example, we will connect to the node called the VLAN API and start to operate on the VLAN parameters of the device. Let's take a look. So this is the next example. It's going to be a lot of kind of unrelated stuff. I think I'm gonna take the moment to quit out here, and then I'm gonna show that configuration file that was necessary for this. So it's ls-pipe-grep.conf. So yep, where's the configuration file? Oh right, it's a hidden file. So -al. So now you can see here .eapi.conf. So we're going to do a cat.eapi.conf. And now you can see the name of my connection. So that's why I can just put in Arista. I don't have to have the actual host name of the device or the IP of the device. It doesn't have to be resolvable through DNS because it's just going to look into this file and it's going to know all the connection parameters based on the name that I gave it, which is Arista1. And then you can see we have the host, username, password. Let's do so let's look back at our LS here. So we can see I changed the permissions on it too. So anyone who doesn't have my user account will not be able to look at my username and password that I'm using for this device. So pretty darn secure as well. It's all around, I think, a better option. And then of course, if you cat out that script that pulls in this, you're not going to see any passwords at all in that script. It's just, I think, the best way to do authentication is to put it in a separate file that you lock down somehow. All right, so import PyEAPI, node equals PyEAPI, connect _to, Arista1, VLANs equal node.api, VLANs, pipe, VLANs, perfect, dir VLANs, perfect, everything's looking really good. And we notice that it's a class belonging to PyAPI, API VLANs, the VLANs class. Okay, so let's do VLANs.getAll. There we go. We've only got one VLAN, VLAN1. So let's take a look at that. VLANs.get one. Oops. VLANs.get, not gets.get. Looks good. Now VLANs.create 10. And I don't know what this true means. Okay, so that's the result. VLANs.getAll. So now we're going to see that extra VLAN 10 that we created. There it is. Perfect. So VLANs.set name 10 my VLAN 10. So yeah, for the most part, I'm really happy with Arista switches. I think if I go for the CCIE next year or something, I'll just be using all GNS3. And if I want to learn about Cisco switching, I'll just use Arista switching. It's pretty much the same thing. I can do all the same things. Commands are pretty much similar. And yeah, I'm sure that'll be enough to pass the test. So let's, yep, we can see we've got a new host name. It's missing the A, but that's fine. So let's do a show VLAN. Yep, and now we've got the extra VLAN 10. As you can see, the Python native API on the EOS object is really where PyEAPI excels beyond EAPI, which we can't even use, and you have to use Python too. So there's a lot of places where it excels over EAPI. It abstracts the lower level attributes into the device object and makes the code cleaner and easier to read. For a whole list of ever increasing PyEAPI APIs, check the official documentation. To round up this section, let's assume that we repeat the previous steps enough times that we would like to write another Python class to save us some work. The py eapi_1.py script is shown as follows. Let's write that out. Oops, now we're going to create another method for this mySwitch class. So notice how we need to include the self parameter because it is a class. It is a method for a class. It's not a function, it's a method. So you've got to include the self parameter. And then when you do a myClass.create VLAN, it's a special kind of parameter. So when you feed it arguments, you don't need to feed it an argument to satisfy that parameter because it's a special parameter as part of the fact that it is a method. All right, as you can see from the script, we automatically connect to the node and set the host name and load running_config upon connection. We also create a method to the class that creates VLAN by using the VLAN API. Let's try out the script in an interactive shell. Yeah, this is what I really like about classes too. You can import them and they make interactive code so much easier because where you would have had to type out all these lines and all your connection things, which you're not even really care about anyway. You want to care about sending commands to the device and receiving commands. It's all taken care of for you behind that class that you defined. Yep, so this is the name of the file. So within that file, we're going to have that class. So if I do a dir on that, you'll see within the namespace there, we've got the mySwitch class. But within this namespace here, all we've got is that py API_1. You can't see the py because it's run off the screen, but it's important to know about namespaces. Oops, my temple's kind of down. Oops. No attribute pi. Oh, okay, yeah, it's going to be my switch, not pi switch. Kind of, no wonder that snuck under my radar there. Connection profile not found in config. Okay, well, why was the connection profile not found in the config? Okay, so, oh, it's looking, oh, okay, yeah. I don't want it to look there. I don't know why the directions wanted me to put it there, but my file is not going to be there. It's going to be home. Yeah. So this will work. Perfect. All right. So now let's do s1.hostname. Yeah, look at how easy that is. s1.running config. Perfect. All right, everything looks pretty good. s1.create VLAN 11, my VLAN 11. Looks good. s1.node.api VLANs, get all. And now we're going to have that extra VLAN 11 that we created. There it is. We have now taken a look at Python scripts for 3 of the top vendors in networking: Cisco Systems, Juniper Networks, and Arista Networks. In the next section, we will take a look at an open source network operating system that is gaining some momentum in the same space, and it's called ViOS. So here's an example for it. ViOS is a fully open source network OS that runs on a wide range of hardware, virtual machines, and cloud providers. Because of its open source nature, it is gaining wide support in the open source community. Many of the open source projects are using ViOS as the default platform for testing. In the last section of the chapter, we will look at a quick ViOS example. The ViOS image can be downloaded in various formats. Once downloaded and initialized, we can install the Python library on our management host. Okay, so we're going to need to get that ViOS. Hopefully GNS3 has got us covered in that regard. So let's add a new template and see what we've got. Oops. If it would let me resize the window. There we go. So I think it's going to be a router. Oh, aha, look at this. We got it. So I don't know why there's an X there, but hopefully that means something different than it's unable to install. All right. Wish this Zoom controls thing would be better out of my way. Okay, this is all open source, so it should be really easy to get our hands on. Let's try to figure out what version they're using. Yeah, I don't see any sort of information about that. Let's just try to use the latest version. Unless there's a one image one. Nope, there's not. So there we go. Let's download it. Oops. Not found. So let's try a different one. Still not found. What about this one here? Oh, it looks like that whole server is just not found. So unfortunately, the links provided by GNS3 are no longer valid, but hopefully on the official VYOS site, they'll still have a way to download. Aha, here we go. So let's see if we can download one of these images. So here's release 1.2.5. We're going to need to get a earlier release than that. Here we go. So BIOS router. Perfect. Not sure how to download it. So here's the free version with no subscription. Definitely want the free version. Okay. Well, so let's see what we can get. So there's the rolling release. I'm not sure what that is. Okay, so rolling releases are built from Git branch name current to build your own. Yeah, so it's open source, so we can just build our own. So I'm not exactly sure how to do that. Let's see here. Branch current. See if there's any tags. So here we go. So 1.2, 2019 Q4. So we've got in GNS 1.2, 2019. This looks like the image we're going to want. So let's filter it out for that. Okay, and then let's do a clone or download. Okay, so hopefully there's some instructions for how to use it. Yeah, here we go. So building installation images. So to build it, you need a Debian 8 Jessie environment. Don't have that. We have an Ubuntu environment. So yeah, I don't know if it's going to work because we're going to need that Debian environment. Yeah. Here we go. Okay, we can create a special environment. So let's do that. So, I think we actually need to install it on a Linux system. So we're going to have our router is just going to be a regular old Linux box with some networking hardware on it, but we're going to be installing this to manage that networking hardware. So let's do that, but we're going to have to kind of treat things a little bit differently, I think. Unless there is a way to get just these images, that would be the easiest way. I prefer to do that. So let's just Google for these image names and see if there's a way we can just get those in an easier way. So we'll search for download. Oh, here we go. Perfect. This is everything I need. So yep, that's going to be the easy way. So I need version 1.2. Looks like I've only got 1.3. 1.2 is going to be quite a bit older than okay, well, it looks like we might have to go, yeah, let's go with 1.8. Perfect. Okay, so now we need for 1.8, we're going to need BIOS 1.1.8, AMD 64 ISO. Perfect, we got it. We're in luck. And then we're also going to need this empty G8 QCOW image, which I don't know how to get. Okay, I think there's a way we can search through the repo, because this looks like it's just the same thing as the GitHub repo here, but the GitHub repo has more tools to search with. So we're going to search for a QCOW. Didn't find anything in that, but let's go and do some different kinds of searching. Oh, yep, this is it. So yeah, I'm not sure where we get that QCOW from. All right, so is this, so this is just, this doesn't look like an actual QCOW, it's just, oh, no, it is, so let's download this. And then, yeah, we can't see it because it's an actual QCOW image, so if we view the raw, well, we're just going to see a compiled file. Oh, well, we'd even have to download it just to do that. So that's why we're not seeing anything, because it is, I think this is the legitimate QCOW image. So let's use that. It looks like it's just something provided to us from GNS. You just need, like, you know, disk space, all that sort of stuff, which the OS isn't going to give you. So GNS just gives you like a generic version of that. So hopefully the BIOS ISO image is actually ready now, though. So we're going to go to downloads and open that. Now it'll pull it in, and then we'll do the same thing for the MTG8. Which hopefully is done downloading by now. It's had plenty of time. Yep, it's done. This is still at 65. All right, so now it's time for the QCOW. Oops, still got to do other things. Oh, there we go. Oh, 1.8.8 is ready to install. It actually found it without having to import that. So yeah, let's install it. And it's going to be vios. So at first, boot the router will start from the CD-ROM, login, and then type install system. So we're going to need to type install system and follow the instructions. So let's do that. So we'll make this bigger here. We'll turn it on. And then we'll open up a console to it. Type install system. And then we will follow the instructions. So welcome to Avios. Oops, it looks like it failed. To start installation, log in and use the command install image instead of start system. I guess we'll just say what it says here. All right, so I'm gonna do a, no, I was gonna pause it and come back to it when it was done, but it is done now. Perfect, so now we've got to do the, I think it was start system. Oh, install system. All right, nothing fancy. Everything looks pretty good. So we're going to need to be also doing a pip install here. So let's do that so that they're working concurrently. You don't have to sit and wait for this one once that one is done. So let's do a pip, oops, install. There we go. So which one should I copy data to? Yep, copy it there. Password, VYOS, VYOS. Yep, that's fine. Lots of things we've got to do, but we're done. So now we can set up our script. We're going to need to log into this. It's going to be .12. I don't know what I can do here. I'm going to need to give it an IP address in order for it to work. So let's do add and do system. Okay, well that's not going to work. Do we get configure? Yes, we do get configure. So we're going to enter configure mode. Let's do so let's try to set up a IP address. So we're going to do set interfaces, and then let's see here. Which interface do we have? We have. Let's try to do a show interfaces. So show interfaces. Perfect. So we've got ETH0, ETH1, and ETH2. So let's do set interfaces ETH0, and we're going to do a, Ethernet 0. There we go. Oh, actually, Ethernet ETH0. Perfect. So now hopefully we can get an IP. Yep, there we go, IP. And we'll do, can we enter an IP? 10.10.12.1/30. Oops. Oh, that's IP routing. Oh, okay, here we go. Address 10.10.12-1/30. So we're going to need to put 12.2/30 on the other one. Let's see if we can copy. Oh yeah, confirm. Or is there like a save or something? Yeah, save. Or maybe it's just good to go. Or like a copy run start or something. Copy system. Config management to, well, it's not that much configuration to lose. Let's continue on. We will configure the interface here. Let's put the wire on there first before we do that. So it's going to be ETH0. Aha, and we got one more left. So ETH5, that's going to show up as ETH8, I believe, on here. So, yep, ETH8 is connecting, but it doesn't have an IP yet, so it's going to fail. So let's give it one. It's going to be a .2. So 10.10.12.2, 255.255.255.252. Apply. All right, we are good to go. So ping 10.10.12.1, that's to the other device. Unfortunately, destination host unreachable. So let's see if we can ping ourselves. We can. Okay, so let's try to figure out what's going on with .1. I'm wondering if maybe the port needs to be no shut, something like that. Let's do a show ints again, Ethernet, ETH0. So it looks good. I don't see any problems. Let's do a configure, or let's do a set, interfaces, Ethernet, and then ETH0. And then we can do maybe a no shutdown, something like that, disable. Or we can do a delete disable. Just like Juniper. Nothing to delete, so it should be up. Yeah, it looks like it's good to go. I don't know why I can't ping it. It's just straight up across the wire, so I shouldn't need any default gateway, anything like that. It just looks like it legitimately, it does have a route to it, but let's yeah, let's go ahead and do a ping 10.10.12.1. Oh, so network is unreachable. We're going to need to probably set up some sort of extra configuration. So set interfaces, Ethernet, ETH0. Oops. Perfect. And now we can do, so we already did address. Might need to add it to a bridge group, the VRF, something like that. Let's look at IP routing parameters. So we can do a few things. That's not going to be it. Can we just straight up do a IP, enter? Okay. Maybe that works. Nope, still network is unreachable. So let's see if we can do a set protocols static route. We're going to do 0 to 0 /0, and then next hop is going to be 10.10.12.2. So now let's see if we can ping. Nope, we can't ping .1, can't ping .2. Network is unreachable. Why is the network unreachable? Show route, is it not showing up as a system? Protocols, static. Okay, show, is there like a show run or something? What do I even got here? I got confirm, I got comment, I got commit. Maybe I haven't committed anything yet. Oh yeah, that was the problem. I hadn't committed any of my config yet. All right, perfect. So now let's go back to the Ubuntu server, make sure that works from there. Perfect. You know it will because we were able to ping it from the other side, but sometimes I like to feel good twice. So let's do this now. We've got the, I'll just see if this went through. It was a while ago, I forget. And it will just say it's already installed too. It's no time lost. Yep, so it's already installed. So let's do by bys underscore 1.py. We're gonna do usr bin env python 3 import g files equals d router 10.10.12.1 password configure set name nation nerd.net domain name. Okay, we can execute the script to change the system domain name. Oops, no we can't, because we could not establish a connection to the host. It looks like SSH isn't set up on it. So let's do a SSH, and then it's going to be BYOS at 10.10.12.1. Connection refused. So this is your big, flag being waved at you saying, hey, you didn't set it up yet, or you've got a ACL blocking it. Whenever you see that message, it's not a reason to be confused. It's a reason to kind of celebrate that you have enough information to know what to do going forward. So let's do that. So we're going to do set, and it's going to be service, SSH, and then, yep, we got to allow root. And then let's just set up service. What else do we need? I'm surprised it didn't, well, maybe if I do the commit. Yeah, okay. So there, it's restarting it. There we go. So hopefully this works. Let's test it. Perfect. Perfect. Now it's going to work. There we go. So we got it back. There was a little bit of a mistake. Oh, wait, no, there wasn't. Yeah, it's not going to give us any output back. It's just going to make the changes. You can, of course, I think, have it do that, but aha, here we go. So message from root at VYOS on none. Active configuration has been changed by user VYOS on PTS/0. Please make sure you do not have conflicting changes. You can also discard the current changes by issuing exit discard. So it looks like I've got a second, yeah, because I had this pound symbol here, I was in config mode just like for Juniper. So this has a candidate config and an active config. And in order to go into the config mode, you type in configure, and then you can do exit to get out of it. So just like a Juniper. So let's verify those changes. Show configuration, pipe, match, domain. There we go. As you can see from the example, the method we use for VYOS is pretty similar to other examples we have seen before from proprietary vendors. This is mainly by design, as they provide an easy transition from using other vendor equipment to open source VYOS. We are getting close to the end of the chapter. There are other libraries that are worth mentioning and should be kept an eye out for in development, which we will do in the next section. Other libraries. We'll finish this chapter by mentioning that there are several excellent efforts in terms of vendor-neutral libraries such as Nornir, NetMiko, and Napalm. We have seen some examples of them in the last chapter. For most of these vendor-neutral libraries, they are likely a step slower to support the latest platform or features. However, because the libraries are vendor neutral, if you do not like vendor lock-in for your tools, then these libraries are great choices. And this is where I kind of, the author loses me, and a lot of people talk about network automation loses me, because it's like, just use Paramiko. Like, if you can log into it and you can send commands over an SSH session, you can use Paramiko. Like, you can automate what you're doing just using Paramiko. And they said, like, oh, well, look at all these extra steps I've got to do. 6. You've got to do 6 extra steps in the example they gave. And that was a particularly complicated example. Like, you can just use Paramiko. Another benefit of using these vendor neutral libraries is the fact that they are normally open source. So you can contribute back upstream for new features and bug fixes. That's really cool, because getting your name on some of these open source projects is really a big benefit to you and a big benefit to everyone else, assuming the work you did is very valuable. Cisco already recently released their PyATS framework. Oh, that's cool. As well as the associated PyATS library, formerly Genie. We will take a look at PyATS and Genie in Chapter 15, Test-Driven Development for Networks. Summary. In this chapter, we looked at various ways to communicate and manage network devices from Cisco, Juniper, VYOS, and Arista. We looked at both direct communication with the likes of NetConf and REST, as well as using vendor-provided libraries such as PyEZ and PyEAPI. These are different layers of abstractions meant to provide a way to programmatically manage your network devices without human intervention. In Chapter 4, the Python Automation Framework, Ansible Basics, we will take a look at a higher level of vendor-neutral abstraction framework called Ansible. Ansible is an open-source general-purpose automation tool written in Python. It can be used to automate servers, network devices, load balancers, and much more. Of course, for our purpose, we will focus on using this automation framework for network devices. All right, so I'm gonna cut it there on chapter 4. I feel like I'm making some decent progress, 24% of the way done with this book. I think the 4%, 3% was just from this morning. So I can expect to get to probably 30% by the end of the day, and then today's Friday, so during the weekend, maybe I can even make it 50% the way through. That'd be great. So thanks for coming along with me. Well, you're not there with me yet. This is going to go live on the 25th. Thanks for watching. Stay tuned for more.